Question 7 says, for the following network, draw a tree. Now, there actually are several ways you could draw a tree. The only rule is, just scrolling back to find a section on trees, sorry, find it here, is that a tree connects all the vertices, all the dots in a connected graph, but no circuits, multiple edges, or loops. So there's actually more than one that you could draw. So yeah, you might have an answer, the teacher might have a different one. Basically, as long as you follow that rule about connecting all the vertices, then you'll have a tree. With a minimum spanning tree though, there is actually a way to draw that, and you'll be using Prim's algorithm for finding a minimum spanning tree. And basically you follow these steps until you've found your minimum spanning tree. So following the steps here, it says choose a vertex, so we start there, and then inspect the edges starting from this vertex. So we've got the edge there, weight 3, 1 of 4, 1 of 9. So we'll go for that one. Step 2, inspect the edges starting from these two vertices. So we actually have a 5 and an 8, we have a 9 and a 4. So actually we can go back to this one because that's the lowest weight. And it tells us now that we have 3 vertices and 2 edges. So 1, 2, 3 vertices and 1, 2 edges. And basically keep going until all the vertices are connected, being careful not to create any loops where you've sort of come back on yourself. So looking at this again now, we've got, coming off the vertices, we've got an 8 and a 5, we've got a 5, a 2, 9. Don't really want to go down that one, even though it's an 8, because that would actually cause a loop. We don't want that. We don't want to revisit any vertex more than once. So probably go for this one. As you can see, it's a bit of sort of trial and error in terms of how to draw it out. From here, lowest one's going to be that one. So 1. So we're getting there now. We've only got 1, 2 that we still need to connect. The idea being that we want to connect all of them. So you sort of got to look ahead a bit as to how to, which one to draw next. So we also don't want to sort of trap ourselves into a loop. So looking at these now, in terms of where to go next, we've got a 9, probably not that one. We've got a 6, we've got a 4 and a 5. So I'd probably go the 4, that's the lowest, to there. Alright, so we're nearly there. So it's pretty obvious that we need to get back to this one. That's the only vertex not visited yet. And to get there, we can go via 5 or 9 or 7. So it actually doesn't say it in the algorithm, but you're actually allowed to do this, which is go back to a previous vertex. Now what you've got is the minimum spanning tree, and you add up each of the values. So we've got a 3, 4, 5, 4, 2, 1. Check that, 2. Yep. So what's that? Then go to mental arithmetic. 7, 12, 16, 18. So, and again, there might be more than one, but for this particular minimum spanning tree, its length would be 19.